guys, greetings from Bulgaria. I am Anton, and in this video we are going to discuss the Singleton Design Pattern. In this course we are focusing on many design patterns that can help us in automated testing. We already covered the adapter and the proxy design patterns that help us to build a mini test library, extending further the 𝑨𝒏𝒕𝒐𝒏 interface, adding new methods and making our tests more maintainable. Then in the second video from the course we checked how we can extend further our mini test library using the decorator design pattern. We added possibility, for example, to create decorators or plugins for highlighting, scrolling into view, building toast messages and logging. And in this third video we are going to focus more on the API usability, and we are going to learn about the Singleton design pattern, or how in another ways how we can access our page objects, factories, builders and other services. In the next video we are going to discuss the dependency injection pattern that can help us further enhance our mini test library, achieving a loosely coupled architecture and building and enhancing the test maintenance. Of course, later we are going to talk about chain of responsibility for building a troubleshooting feature for our framework. We're going to cover strategy design pattern for waiting and finding strategy to our framework. We're going to discuss different test data management techniques and learn about factories, repositories and builders. And last but not least, we're going to cover the data-driven testing, so that we don't need to always copy-paste the body of the test, but instead reuse one test for many test data parameters. So, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified about the many new videos that are published each week. Also check the Lambda test blog. There are many detailed articles about many best practices in test automation. And of course, check the links below. You'll find many resources. I'm going to remind you about some of them during this module, and you can get and download and clone the GitHub repo. You will find it in the description below. So let's get started. First, let's just a quick reminder for what is a design pattern. Then we're going to define the problem and we will directly start refactoring our solution. I'm going to quickly remind you our previous version that was based on the adapter. If you missed this video, check it out. And so, what is a design pattern? It is we can define a design patterns as prescribed solutions to everyday software challenges. They don't consist of code or any specified algorithm, but instead they describe how to group your logic smartly, reuse it, or to make it easier to maintain. To put it simply in one sentence, it is a template for solving design problems which we can use while we create our software solutions. So, what is the problem? Just quickly, I won't spend time creating these tests. In more details, I did this in the previous modules. I will quickly just show you the version that uses page object models and the adapter design pattern. I will quickly show you and explain all of the parts. But here are the two scenarios that we already implemented. They're middle complexity, since if the test is just too basic, then probably you don't need to use design patterns, but you can directly use Selenium, alright? So the first scenario that I built tests for is when you search a product here, and when you click on the product, by the way, here we select the product from the autocomplete using the product ID. You can check the previous video about how we write this dynamic locator. And also there is a tricky part here, since this expansion is, you need dynamically to wait for it. We already handled this with the adapters. So we compare this product then we can return to the main page. We can search again for yet another product. We can open it, we can add it to the compare. Then we can click here this compare or these two arrows, and we will navigate to this particular page. We abstracted the logic in our page object models. If you're not familiar with the pattern, please check the links below. There are a few articles about it and also a few videos on the YouTube channel about the page object model. But in short, the page object models are classes that they contain all of the web pages, web elements on a particular web page. So in a single place, you have how we locate the web elements. We have all of the actions that we can do. For example, filling the login form, the registration, or the purchasing form. And in some variations, like mine, I like to put the assertions inside the page objects, since in more complex scenarios, there are additional mini logic inside the assertions, how we get the information to verify it. And also we can wrap there some exception messages to be thrown when the assertion fails. In this particular scenario, we abstracted some logic and made our methods more abstract so that they can support more than two products to be compared. And if we need to verify this information here, we provide the data, as we'll discuss in a minute, through model classes. These are simple classes where they have properties instead of having multiple parameters like 7 or 8, because this is not the best practice. The best practice is to have up to, for example, 5. More than that is making our tests more harder to maintain, harder to read, etc. So everywhere we are using these simple model classes that they basically group our parameters. So in order to verify the information here and to find it, we have special methods based on these labels. We use XPath locators, XPath access. Check in the links below, you will find an article more detailed how to write such locators. But basically through this label, in this HTML table, we are finding this particular row. And then we have a second parameter that it's basically the column index. This is column index 1, column index 2, 3, 5, no matter how many products you have. This is our first scenario. The second scenario is how we purchase a product. So we can pick this a product here. We can increase the quantity and add it to cart. Then we are going to click view cart. We can increase it from here or not. And most again, here we can write many automated tests to verify multiple things. However, we're focusing just on a single workflow, where we'll just check here the total price. Then we are going to click checkout. Again, on the next page, we are just verifying the total, nothing more. There are hundreds of test cases here. There are other videos on the YouTube channel that we are discussing them. But here we are automating the basic flow where we are filling this required information. We are checking the, we are agreeing on the terms and conditions, and we are clicking continue. Again, there is a tricky part here with the JavaScript. Check the previous videos in more details to see how we handle this, but basically we need to scroll. That's everything. Now, let's return to the code. Actually, just let me remind you the diagram about the adapter. The adapter, we use it to extend the iWebDriver, and we have this interface iDriver where we have additional methods like wait for Ajax. We have a method start, that it's a factory method for initializing the driver. Also, instead of find element, we have find component, and inside this find component, in the actual implementation, which is called driver adapter, this implements the iDriver interface. We are creating the component adapter, which is a similar implementation but for the iWeb element. And this component, the way it extends the iWeb element is that Now our components know how they were located with the this by property. Also, we have new methods or modified ones. Instead of send keys, we have type text. We have new methods like hover, etc. And in the actual implementation, again, we basically, through composition, we hold a reference to the actual iWeb element. This is, in short, our current implementation. So let's review it. As I said, I'm not going to type anything. I'm just going to explain through the code really quick, and then we are going to refactor it through Singleton. So in our current implementation, we have this all of these page objects. We have a base class called 𝑨𝒏𝒕𝒐𝒏. It's an abstract class. It means that you cannot create instances of it. We just use it as a base for our page objects. We hold references here to the iWebDriver, WebDriver weight, actions, etc. Actually, I'm going to review this version here with the iDriver. Here we have, instead of iWebDriver, we have the iDriver interface, which is the new modified interface. As I said, we have the start, we have the find component, etc. Check the previous video about the adapter. It's quite interesting and quite useful. So this is the actual implementation. The only thing that I did is that we are implementing the iDriver interface. As we discussed during the module about the decorator, you can achieve this through interface or through an abstract class. It doesn't matter, it's the same thing. So we have we use 𝑨𝒏𝒕𝒐𝒏, the composition principle, which is in quite popular principle in object-oriented programming, where basically instead of inheritance, we contain instances of other classes that implement the desired functionality, like here, like private instances here. We can nest them through the constructor, or basically here in the factory method I'm creating them right here. But this is especially important in languages like C# and in Java, where we don't have multiple inheritance. And like Lego, we can have multiple instances. This is quite better approach. So in our driver, as I said, we have the start, we have the find component where we are waiting for the element to appear. We are creating the component adapter, we return it. That's the adapter. So if we return to the page, as I said, we have just a base web page. In all of our pages, we just provide the driver to the constructor, to the base page. From then, after that, we have like properties, public properties of the elements, how we locate them. This is really great pattern where if there is a change in the locator, we're going to change it just in a single place. And after that, we have all of these methods that group all of the logic. They hide all of the nitty-gritty details, for example, whether we need to wait for Ajax, whether we need to scroll, etc. This is hidden inside the page object. As I said, we can have assertions as well. In my books, I describe 10 variations of the pattern. In some variations we put here the assertions, in others we don't. It really depends what you want to achieve. So for example, the checkout page, as you can see, we have many such elements. We have methods like filling the user data. As I said, instead of having, for example, 5, 6, 7 parameters, we use these so-called POC objects or model classes, where we have these properties that have getters and setters for providing the data. This is making our tests easier to use in our API. So we have these methods here. This is creating the so-called DSL or domain-specific language. And when we check how we use the test now, like here, by the way, this is a regular NUnit project. If you're not familiar with NUnit, please check There is a whole course about NUnit. There is an NUnit certification on the Lambda test website. There are tutorials on the blog. Really quick, when you click NuGet packages, we have installed these 4 NuGet packages needed for NUnit. Also, the most important dependency, of course, is Selenium WebDriver. And I have a few other related Selenium NuGet packages that are for backward compatibility, especially the WebDriver Manager. If you are using Selenium WebDriver 4.11 and above, you don't need the WebDriver Manager, because basically in the newer versions they use the new Selenium Manager functionality that downloads the drivers automatically for you. And if we return to the tests, this is a regular NUnit test class marked with this test fixture attribute saying this is a class that contains NUnit. Then we have the setup. Basically, this is a test init method called before each test. Here is the place where we start the driver or the session. This is executed before each test. This is executed after each test. We are closing the browser or the session. So this is the place, if you use the Lambda Test Cloud, this is the place where you put your capabilities from the capabilities generator. So it doesn't matter. Here I'm using walk-off driver so that you can test it. After that, as you can see, if we use the page objects, by the way, I missed this, but I have this class, sometimes this is called app design pattern in my books, or a common class that basically holds references to all page objects. I prefer to use it instead of having base. We can still have base class for all of the tests, but basically this class is responsible for holding reference to all of our page objects. So this is the place in its constructor where I'm initializing all of the pages in a single place. This has the benefits where if I make a huge refactoring of what we accept here in the constructors, I'm going to change it in a single place, rather than, for example, if I have 20, 30 test classes, then I will need to go to many places to update the constructors. This is the benefit. And the second benefit, as we'll discuss later, is that when you use the dot, you have access to all of the pages and you know what they are. Since when we discuss the singleton, our tests are shorter, maybe easier in some cases to use it, but you don't know what are all of the pages. But it will be up to you. It's a matter of choice and preference. So we are initializing here the model classes or our test data, and then as you can see, our tests now are quite readable with the page objects in this pattern. We built this DSL or domain specific language. They're reading the test cases. We're reading them as sentences. They're quite readable. So this is what we have until now. Now let's discuss the Singleton Design Pattern. The Singleton Design Pattern is basically quite simple. Maybe this is the simplest design pattern of all that we are going to discuss, but basically this gives you only one instance and it provides access to it. That's it. We can achieve this in different ways. The basic implementation is quite simple, as you're going to see in a minute. However, especially when we want to execute our tests in parallel, this makes our job more challenging. Because if you use a single instance, then there will be maybe problems, there will be deadlocks, because you're going to access a single instance of the driver or the page. So we need to solve this, and we're going to discuss at least 4 ways how we do that, and we're going to compare them, and then we're going to refactor the code that we have before. But now let's just give you an example. I have a version here with this is the no singleton version, right? This is how we use it until now. Then we have a version where we use the singletons. So this is a single version. This is usually how it works. In the Singleton, in Java, for example, you're going to have, like in the diagram, a method called getInstance because we don't have properties. In C#, you're going to have a property called instance. And this instance is responsible for the first time when you call it, it will create an instance of the object. And the next time when, for example, like here, the next time when you call it, it will return the same instance of the page. And in our case here, I made this thread save. It will return the proper instance for the particular process. So we're going to save an instances. We're going to return them based on the particular thread or a process where we create them. Let's now, I created here a copy of our adapter so that I can show you a simple refactoring of how we can create the basic versions of the pattern. So in the most straightforward way how we can implement it is that we need a static private variable to the same class. In our case, this is the cart page. I'm going to call this instance, and then here I will have a static property that it's going to return the same class. In our case, this is the cart page, and as you saw, this will be called instance. Now we need only the getter, we don't need the setter. So here we need to have a check whether the instance is null or not. So here I will create an if where we check whether the instance is null. If it's null, then we are going to initialize it, and we are going to return here the cart. Now I'm going to do the refactoring later because since we need to pass the driver, I need to refactor the driver adapter as well. In a minute I'm going to show how we can do that. For now I will just pass new, but imagine that we are like passing here as a singleton the driver adapter. And next we can return here the instance. Or you can do it like this. For example, in C# we can use this syntax instead of having this, and then we can make it even shorter like this, or even shorter if we have just get, we can make it like this in a single place. This is the singleton. Excellent. Now as I said, this is not thread safe, and also the problem here is that every time for every page we need to create that. As you can understand, this is a lot of copy-paste code. We don't want that. So we can move all of this logic into our web page and make this base page maybe generic, so that we can reuse the singleton. So let's create that, and I'm going to rename it to basic singleton. So in this version, base singleton, we don't need this constructor anymore. In a second, again, let's accept that probably we are going to use this driver as a singleton as well. Anyhow, we need to pass the type of the page, so we are going to provide here a parameter called tPage, and we need to have this constraint where we need to mention that tPage is actually a class, and probably that it contains a constructor. And now we can have a private static tPage instance, and below that we can have the property that will return tPage. It will be again static. This will be called instance, and let's write the regular version with the get so that it's not too short, because I know that this is hard for some people. That's completely fine. And we can check whether the instance here is null. Here we are going to create new t page, and then we are going to turn the instance. This is how we created the web page basic singleton. And now if we return to our cart page, now I can change it like this and use cart page here. Again, we need an empty constructor now, and here we need to remove this one here. Again, we are going to initialize this driver. Imagine that we are going to get it through a singleton in a minute as well. So yeah, that's it. And everywhere we just need to do this refactoring for the checkout, for the home page, etc. Again, this is in the most straightforward way, where we don't execute our tests in parallel. If you don't plan to execute them in parallel, that's completely fine. Don't go and implement the other things that we are going to discuss now, because this will make your test much more harder to maintain and more complex than needed. There is this principle in software programming where if the simple, more straightforward solution is working for you and the code is equally maintainable, then don't go and write something more complex. Now let's review the other solutions that are thread safe, meaning that you can use them in a way that basically solves this problem. The first version is if you use this thread static. Again, if you watch here, this particular base class, it accepts a generic parameter t. Again, we mentioned that it needs to have an empty constructor. It's similar to what we created before with the basic version, but now we marked our static variable with this thread static attribute. This indicates that the value of the static field is unique for each thread. This provides a separate copy of the field for each thread or for each process. However, it requires careful management to avoid memory leaks, and the initialization is not straightforward as in other methods. Now, we have another version that if you clone the repo, you're going to see it. It's much more complex. It uses this internal static class singleton factory, where through reflection we are creating the instances. This is another way. I'm not going to discuss it now because it's not my preferred way. Instead, we are going to check another version that it's using the native lock mechanism in C#. This lock mechanism, how it works? Again, we have the generic parameter, we have the generic constraint, we have the private static variable, but we have a new static variable that it's read-only of a type object. And we are creating one instance of this lock object. And the big difference here is that we wrapped our basic singleton version inside this lock. And this is using this locking mechanism that ensures that only one thread can access a certain block of code at a time. This is achieved through this lock. So, what are the pros? This is simple and straightforward to implement. It guarantees a single instance in a multi-thread environment, works well for lazy initialization. It can lead, however, to performance issues due to thread contention, especially if instance is accessed too frequently, and it has an overhead of locking even after the instance is initialized. Again, maybe in our case in automated tests we are not going to access it so much more, so maybe it's fine to use it. However, I have two other preferred ways. One of them is using thread vocal. This solution, for example, if you use Java, it's the solution for you. In Java we have thread vocal as well, we don't have lock. So this thread vocal solution is it provides a thread specific data storage. Each thread has its own instance of the variable. This particular container, we initialize it through these lambda expressions, where we create again the object. And in order to access the actual storage, thread safe storage, you need to access it through this value property of this instance, this static instance. It works the same way in Java. So it ensures this thread safety without locks. It provides each thread with its own instance, which is useful. Behind the scenes, how it works, it ensures, again, each thread has its own instance. On the first access by the thread, the variable is initialized, typically via provided lambda expression. Sequential accesses fetch the thread specific value directly, avoiding contention and ensuring thread isolation. Setting a value stores it only for the current thread. It's crucial, however, to dispose it of the thread local property to prevent memory leaks in long-running applications. Probably in our cases we're going to run our tests for many minutes or hours. The performance benefits comes from eliminating this locking overhead through memory usage. However, the memory usage might increase with the number of threads due to each holding a separate instance. However, probably in our test we won't have so many threads. Now, this is why I implemented here this 𝑨𝒏𝒕𝒐𝒏 interface, and I implemented this dispose method. You will notice here that I use this encode specifically the garbage collector. This using of garbage collector suppress finalize is particularly important for classes that manage unmanaged resources like threads directly or indirectly. It ensures that the resources are released as soon as possible without waiting for the finalizers to be called, which might happen much later or undetermined at particular time, potentially leading to resource leaks. In my case, where we use this website class, here I implemented the 𝑨𝒏𝒕𝒐𝒏 interface as well, and this leads to basically this forces you to implement the dispose method as well. And if your pages are using the thread vocal base class, then here you need to call everywhere their dispose methods. In NUnit, we need somewhere to call this dispose method of the website. So in NUnit, the proper place to call this is this global test tier down. In MS Test, we have a special attribute called assembly cleanup. So the proper place to put these dispose methods is in this assembly cleanup method. Basically, this assembly cleanup method or run after all tests, as you can guess from the name, this will be run after all of the tests, and this will dispose all of the pages. So in NUnit, we do that with this one-time tear down attribute. The important thing here, if you read later all of the descriptions here, is that you need to put this inside the global namespace, not in a specific namespace. So the last version that we are going to check, in my preferred way in C# is using this lazy class. So you will notice again we have the generic, we have the constraint, then we use this lazy. So the lazy is a feature in C# that allows you for delayed creation of an object, meaning that the object is only instantiated when it's first needed, and it's thread safe by default. Lazy initialization is not created until it's needed. It has this performance benefit that no lock overhead after the instance is created. It has internally slightly more complex implementation, but you don't need to care about that. You just need to use it. Again, just lazy t equal to new lazy, provide here how we are going to initialize the proper object. Like with the thread local, you need to access it through this value attribute. So in my refactoring, the thing that I did is, as I said, we need to refactor the driver adapter to be singleton as well. So I have not thread safe version. If you need that, you can use this version. As I said, if you're not going to run your test in parallel, use this version. Otherwise, I implemented this lazy driver adapter. As you can see here, we are creating the new driver adapter. If you use decorators to further extend your mini framework, then you need to initialize the decorators right here. After that, in our pages, in our web page, I'm deriving from the thread safe lazy base singleton, where we provide the T page, similar to how we implemented the first time. And as you can see, now our constructor is not accepting the iDriver interface, but instead we have an empty constructor, not an empty, but without parameters, and we are accessing directly the driver adapter from the instance property. Again, this is thread safe, meaning that you can run your test in parallel on the Lambda test cloud, and this will work as expected. After that, you just derive as usual from the web page that we refactored, just mentioning the actual, we are exchanging the T parameter from the T page with the actual class type. That's all. Again, if we don't use singletons, we access it directly from the web page, or maybe you can skip the website class and you can use the web pages directly from the instance property. Some people prefer that. Also, this is not only for related to page objects. Later we can use it for factories, for repositories, for builders, for whatever classes you like. This is actually a version where we use website singleton and we access singleton versions of the web pages. So you have multiple versions to pick from. This is what we covered. So what we covered here, we reviewed a solution with page objects without singletons. We use the adapter, then we refactored, and the singletons help you to have a single instance of a class, but without without making all of your methods static, because if you do that, you cannot use base classes and reuse all of the logic. However, the singleton gives us both of the benefits. We can still derive from base classes and still have a single instance. And we reviewed a few solutions with thread local, with the walk object, with lazy, with this thread static attribute, how we can achieve thread safe versions of these base classes of ours that give you the Singleton Design Pattern. And again, if you're not going to run your test in parallel, just use the base version of it. In the next video, we are going to cover the inversion of control principles, so stay tuned. Please put any comments below, and also I will gladly hear what patterns you want to learn more if they're not in our series. So thank you for watching. Check the Lambda test blog for more helpful articles, and of course check and get your free certifications about JUnit, Selenium, and other technologies. Thank you, and see you in the other videos.